Well, hello friends. Welcome back to the program. Today we are going to write some code in Jakt, and I just want to take the language for a spin, basically. I did that pretty early on and wrote a JSON parser, and today the language is much further along, and I thought it would be interesting to do something a bit more complicated. And what we're going to do is we're going to model a very, very simplified browser engine core, I guess. So we're going to make a DOM tree and create like a little DOM tree, not parse HTML, but we'll instantiate the tree manually. And then we're going to make a CSS selector and run it against the DOM tree to see if it matches an element. And I thought that would be kind of interesting to see if we can model this in Jakt in a way that looks nice, runs nice, and is understandable. So first thing I'm going to do is see if I can get rid of the activity bar. Hey, look at that. I didn't need that. And then let me make a toy web. We'll call it toyweb.jakt. And this is just going to be a tiny toy web engine model. So we're going to do just a basic DOM class hierarchy here. So it would look something like this. Actually, there's a parent node class here as well. Okay. And then they need to have pointers so that we can traverse the tree. So we need to have a first child and a next sibling pointer at least. If we don't want to traverse backwards, we at least need forward pointers. So let's see if we can do that. So, we could also have a vector of children. Vector of children versus, you know what? Let's make it simple. Let's just have a vector of children. So this will be a no children, right? And every node will have a parent, which will be a weak node because here these are strong references. So the pointer back to the parent has to be weak. Okay. And then we don't worry about sibling pointers and stuff like that right now. Okay. And then elements, of course, can have attributes. So we can store that as a dictionary of string to string. And yeah, let's see if we can build something like this. And then let's make a construction helper. So we'll have a create function that takes a tag name and returns an element. And we're going to need to store the tag name, of course. So we'll just do it like this. And then let's see. So here we have to initialize all the parent classes as well. Although I guess we don't need to if we do this. If we give them default values, is it possible to do that? It's not possible to have a default value if the default initializer throws. So that's an interesting thing. Should probably make a fix me about that. Allow in default initializers. Member default initializers. I'll put that here because that would be very helpful, because the way it is now, I can't do that because it might throw. And that means that I have to actually initialize it here instead. And this has to be a throws function, since creating a new array is a heap allocation, which may throw. Okay. We also need tag name and attributes like that. Okay. So I think given that, we should be able to create some basic elements here. So we'll make an HTML element. Tag name HTML. That's not good enough. Oh, because it's not, we need to make it public so that we can call it. Cool. So let's make HTML, maybe a head. Make a HTML head and body. All right. And then maybe we will append child head. So we'll put both the head and the body in the HTML element. And of course we need some append child function, which would go here in parent node. And it will take a mutable this, since it's going to mutate one of the members. It may throw, since we are appending to a dynamic array here. So we would just say children, push, and then the child that we're getting. So the child is going to be a node. And I think we don't, since it only has one parameter, and what the parameter is already implied by the name, I'm just going to make this anonymous so that you don't have to say child colon here, right? Because it's kind of redundant. If you're writing code that looks like this, like append child, child head, that to me is redundant, and this looks just fine. Whereas here, I would say it's less obvious what this is. I mean, you can kind of infer from context that like, oh, that's probably a tag name, but this is a bit more explicit, which I dig. Okay. So let's see, I should maximize this probably. And let's find out if this actually builds. That would be interesting. We should probably keep track of that. Oh, do I not even have a build of Jakt? I did not. Hopefully it's relatively fast to build it. Okay, anyway, let's see. So we're also going to need a text node, I guess. And let's make a whole title thing, actually. So head goes in HTML, and then title is going to be head, append child, title. And in the title, append child, we're going to put a text. A text node with the text, well, hello, friends. All right, just had to cough there. Not completely recovered, it seems like. Okay, so let's see. So the text node is going to be here, because text can't have children. It's not a parent node, it's just a plain node. And it's going to need to have data. Okay. And yeah, something like this be pretty good. Okay, and can we run it? We can, and it does nothing, of course. But hopefully we are instantiating these things. So let's write a recursive dump function that can just dump the whole tree. And let's see how that goes. So dump tree. Something like this. Okay, and then, oh, we're gonna need some indentation here, actually. like something like this. And then how do we print out the indent? We have string repeat, I think, repeated. You can do something like this. That's not how you do that. Repeat, repeated. Okay, I have to look in the prelude. Repeated character and count. Okay, my bad. Almost remembered. Okay. And then after that, we will print out the node. We want to print out node name, I guess. So let's add a virtual function for that. Public virtual function node name. Can we do, is this possible? Oh, it can't be virtual and not have this pointer, of course. Okay, text, and this is override. Yeah, and then we just put these on everything, see how that goes. And then, wait, why can't I call node name? Oh, it needs to be in a throw-z context. Sure. All right, and then we need to iterate over the children. Still, and actually, let me call the function before I forget. Dump tree HTML. There we go. So it only prints the root right now because it doesn't actually recurse into children. So here we'll say if node is a parent node, then for child in node as parent node dot children. Can we do that? Oh, it's not public. Children are not public. So just make it public. Okay, and then we iterate the children and dump tree child. And then indent is indent +1, I guess. Hey, look at that. That's pretty cool. Okay. And then I think the node name of an element should actually be, these shouldn't be the class names, but this should be more like the tag name. So since here we have a tag name, we should return that. Yes, look at that. It's starting to shape up. Okay, and we could even put it into some of these things. Maybe we will multiply the indent by 2 just for effect so that it stands out a little bit. Okay, starting to get better. And then for text, text nodes, instead of doing this, we could also not print the node name, but instead, if node is text, then do something, otherwise do the node name. So just like this, node as text dot data, which is not public, but it could be. Okay, pretty good. So far, so good. It's a nice little DOM tree. Let's put something into the body as well. So how about an H1? Okay, body append child, H1. And in the H1, we'll put some text. Like header. Welcome. Welcome, and then a cute smile face. Perfect. Okay, so this is really neat. So far, we didn't really hit any pain points. I like that it just kind of lets us do this. There are some things that feel a bit awkward, like giving direct access to members by making them public instead of having accessors, which is what we normally do in our C++ code in Serenity. But for the purposes of this program, I feel like this pattern is all right. I don't know if we would end up writing code with accessors. The main argument against accessors right now is that we don't have the faculties to make them efficient because we don't have enough like lifetime comprehension in the compiler yet to do something like returning a reference to a member and then proving that it can't go out of scope, or that it can't be destroyed while you have a reference to it. So because of that, direct access to the member is something where we know statically that the base is not going to go away while you're manipulating the member, because the base is part of the expression. Anyway, this is nifty. Let's make a little CSS for this as well. So I want to make something like a selector that then we can use to match the H1 element. That would be cool. And we can make it like a little bit complicated. That, let's see, what do we want to do with that? I guess we can make like a selector that would be something like this, like HTML body H1. So we could make one like that. We could also make one that's just like this. We can make a couple of different ones actually, and then we can make them more interesting, like giving it an ID, for example. Yeah. Okay, let's just see. So this would be something like enum selector. I'm trying to remember how we model these in libweb without looking. I think we have simple selector, and a simple selector is either universal, which is like the universal selector, or it's a tag name like HTML, or it's a class, foo, or it's an ID. Yeah, something like that. And then you could also have pseudo class and pseudo element selectors, but let's ignore those. Okay. And of course, universal doesn't have any fields, but tag name needs a field, so just a string with the tag name. Actually, all of these need a string field. All right. And then let's maybe line these up for aesthetics. Okay. And then we need to put the simple selectors into a, is it called a complex selector, or I forget the names. Complex selector. I think a complex selector is when you have something like HTML dot foo pound hello. This would be, they all match the same element, and it would be like an HTML element with the class foo and the ID hello. I think those are complex selector, which would then be like a list, and it's going to be a struct. So it has a list of simple selectors. Actually, you know what? Let me go and let me look at, just so I'm getting the right names here. Let's see. Simple selector is like the different selectors that I just made an enum for. Sure. And then, is it called a complex? No, compound selector. Compound. Okay. Compound selector is one of those things, right? And the way we model it in libweb today is that we store a vector of simple selectors and then a combinator, which sort of tells you what type of glue it has between this compound selector and the one next to it. So in a selector like this, for example, the combinator is this thing. It's the immediate child combinator. So let's do combinators as well. Combinator is going to be either no combinator, which is what you would have. The leftmost combinator in any selector would be none. Immediate child. Let's just start with those. Okay, and then finally, a selector is going to be a list of compound selectors, I guess. Okay. So let's make a function that creates a compound or creates a selector. We're not going to parse because I don't want to write a selector parser right now. We've already done that before, and I'm sure we'll do it again someday, but not right now. So let's see. We're just going to make a selector that has compound selectors. I guess we can just return that once we have the compound selectors. Okay, so that's going to be an array of compound selectors. And wait, why can't I do that? Oh, because we don't have a return type. Of course. So let's see, which selector are we going to make here? We're going to make, just make a simple H1 selector that has nothing on the left of it. It's just this exact selector, H1. That would be compound selectors, push, compound selector. Combinator is going to be combinator none. Simple selectors is going to be, we're going to have simple selector. Can we build it like this? This is kind of cozy. Simple selector. Oh, that just needs to be one of those things. So tag name H1. Okay, this is really tidy looking, actually. Okay, so we'll call it make H1 selector. Okay. And then let's say matches is H1 selector, matches body. And we'll also run it on the H1 element. Okay. Okay, so H1 selector matches body, and then yes or no. This is a little bit goofy of a program, but whatever. It's going to be okay. And then we need to implement a function called matches here. So how is that going to work? Matches this bool. Okay, so this thing basically needs to walk the compound selectors and check if they match what we're looking at. So the simplest possible approach to this would be something like for compound selector in compound selectors. Oops. Wrong number of arguments. Oh, yeah, of course. I have to take an element. There we go. So it doesn't match anything right now, of course, because we just return false. But here, I guess we can ask if the compound selector does not match the element, return false. Okay, and then we will make an API for that. Okay. So for simple selector in simple selectors, if not simple selector matches element, return false. And if we get to the end, we will say true. Okay, and then we will add an API here, matches. Enum methods are so cool. I really like being able to add methods to these things. So actually what we want to do, I guess, is say match this. So universal matches everything. Maybe we can write this as a FAMF, as a fat arrow match function. Might be kind of awesome. True. Okay, tag name. Element tag name equals tag name. Wait, does that make sense? Tag name is private. All right, we can make it public. No problem. Class. Element has class, class name. Yeah, we'll need to add those APIs. Maybe we'll just say class underscore. Get attribute ID equals ID, something like that. Okay. Get attribute. And for now, maybe we just say this, but fix me, return attribute. Okay. Fix me, return whether class is present. Okay. It's very nice looking. Okay, so this extremely primitive matcher can verify that H1, the H1 element indeed matches the H1 selector. So far so good. But what if we make it a little bit more complicated and say that the H1 has to be a child of body, let's say. H1 has to be a child of body. So we'll make a second one. Okay. And, or you know what, we will make one. No, this is good. This is good. Body greater than H1 selector. So we'll push two compound selectors. And actually, I guess we could have done this without, could we have done this as one big thing now that I think about it? like this. Ooh, look at that. That's pretty cute. Okay, we can definitely do stuff like that. Okay. So this would be body would come first, and then H1 with an immediate child combinator. And then we have to start from the end of the list of compound selectors when matching. So we start and match against this. And if it matches, then we sort of traverse the DOM based on the combinator one or more steps. In this case, only one step. So let's see how that would work. Let's see. So we have an element. I guess it would be something like current is element. And then if compound selector combinator is none, that means that this is the leftmost thing. So we actually shouldn't be none here. Which reminds me that we don't have a way to save, like we don't have verify that we have in C++. It would be a nice thing to have. So we are going to say what am I trying to do? If compound selector combinator is immediate child, then current is current dot parent, and I bet I have to make that public. Also, what's up with that? Is that auto formatting? Oh, that's an unfortunate auto formatter. Yeah, the auto formatting is not perfect yet. This is an example of something that it doesn't do right. Okay, so we go to the parent. This doesn't work because parent is a weak node. Yeah, of course. And it might not be element. Interesting. Yeah, actually, there might not be an element. The root should probably be a document node. And then document should be the root, yeah. So let's create that real quick here. Document is a type of parent node. And the node name is going to be just plain document. Do I have to say throws like that? I don't think I do. Anyway, let's ignore that. Okay, so create what do I have to do here? Wrong number of arguments. I have to specify the children, right? Current.parent is a weak node, right? This type mismatch error message doesn't read right to me. Expected weak node, but got element. Current is an element, so I'm expecting an element, but I'm getting a weak node. So I feel like this type mismatch error message is backwards. Yeah, it's an assignment between incompatible types indeed. Okay, so we have to check if current parent has value and current parent is element as element. Can we do that? That works. All right. So then let me just tidy this up a tiny bit here. And let's make the other selector. So H1 body GT H1. Okay. That does not match the H1 selector. Okay, why not? Let's see. Body H1. So the first element in it would be body. Oh, right. Yeah. We have to go backwards. We have to go backwards. That's what I was saying. So we don't have a way to go backwards in an array, I think. Reverse. Backwards. Yeah, there's no backwards iteration. That would have been a nice feature. So I would say, fix me. Add something like for reverse iteration of array. Yeah. E.g. for element in array in reverse. That would be cool. But what we have to do instead is index in, I guess we can just say I in. Oh, I think we have some kind of thing for this. I forget exactly how that works. Reverse. No? What the heck is the backwards reverse? There's some backwards thing. Shoot. I have to look in the prelude. Range. Well, there isn't a reverse range thing yet. Okay, my bad. I thought there was. So I guess we just have to make something. I guess I have to go forwards and then trick it. This is not the most beautiful, but I guess it is serviceable. Okay. Compound selector, compound selectors, index. Then we are back on track. Still doesn't match. Okay, let me log these then. I'm gonna have a look at what we are actually matching. So index and compound selector, let's just print those out. So we're trying to match this guy, and we start with the H1, and that is gonna fail on the body element, of course. On this guy, it succeeds. And we proceed to the next one, I think. Yeah, because otherwise we would return here. Okay, and then current should change to the parent. Oh, but we never set the parent when we append the child. I think we never actually, we just pushed it to the list of children, but we never said child parent is this. Can I do that? Assignment to immutable variable. Wait, what? Oh, wait, hold on. Append child. Assignment to immutable variable. Mute this anon mute child. Yes, because we're going to mutate the child by setting its parent. And then it works. Okay. Yeah, so now this selector matches H1. Because we go up to the parent and then match the simple selector body there. That's pretty cool. And I kind of want to add an attribute to something. So let's make a little div, I guess. Element create tag name. A div set attribute. We'll give it an ID. And, well, hello friends, that's a pretty cool ID. And then we will add it to the body element. Okay. So then we need to create the API. An element for setting an attribute. So public function set attribute mutable this name and value. And then here we'll just say attributes name equal value, something like that. And there we go. We should probably dump that. So in the dump function, let's see, if node is text, then we do that. Sure. Maybe this should become a match. Text. This will be the else. This is kind of interesting. When you're matching on class type and you're matching on its class, you're matching on the class type, then at this point, you know that node is of type text. So this cast here is entirely redundant. And I wonder what would be a good syntax to capture that fact. I guess you could allow something like that, but like that syntax, we use that for fields, and it feels a bit weird to do it with node itself. So you're kind of renaming node. You could do something like this, right? Like text as text node. I don't know what syntax you would use, but like something to bind, to rebind. Maybe you could rebind node actually. As the, you could rebind node as the more narrow type. That might not be what you want in all cases though. Yeah, maybe just having some syntax for binding the narrower type would be interesting to get rid of this cast. I don't know. I don't know what good syntax for that would be, but it would be a cool thing to have. Anyway, if it's an element, then we want to do this, but we also need to put out the attributes, if any. So for name and value, wait, can we do this in node as element dot attributes, which is probably not public, which is again keeps being an issue that I don't make these things public. That's probably a me problem. Name value, right? So we're iterating the attributes. I feel like the the IDE inlay hints are a bit overeager. Like it's telling us the name is a string, value is a string, but I don't need this information here because you've already given me the information here. So that's a bug that it's saying string here. Makes the line way noisier than it needs to be. Anyway, we will print out the attributes. So maybe something like this for simplicity. And we'll just put a little space after, or maybe a space before. Space before is better because then it will look proper. Ooh. What am I doing wrong? Finally, something doesn't work. Let's see, is it this code that I just wrote that's broken? Yes, it is. Okay, so you don't like this, or do you like it? You don't like it. Which part do you not like? Maybe I can't match on a class type. I just imagine that you could. Was this okay? It wasn't. Was that okay? It was. Okay, so it seems like we're not able to match on class types. I thought we could. So that's fix me for sure. To allow matching on subclass types like this. I think that would be a really nice thing to have, especially when combined with rebinding facility. Okay, so I guess we are stuck with if node is text. It's nice to do this kind of exercise because you end up discovering a lot of little things that, that can be better. Dun, 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 dun. Okay, what about that? That worked better, yeah, you like that? Okay. Oh, shoot, I need to actually make that terminate the line. There we go. And then we have our attribute as well. I need double quotes. Just because it looks nice. Okay. That's pretty slick. Let's see if we can make a selector that matches the attribute. That would be cool. Just for funsies. So make div WHF selector. Div ID WHF, let's say. So this would be actually just the one. So it's going to be a simple selector div, but it needs more than one simple selector. So it will have that one, and it also needs to be ID WHF. So it's div WHF like that. And let's see. This could definitely be structured in a more beautiful way. Let's see. Maybe I will cheat and give the selectors a selector, a text thing that we can just put there manually. Text H1. Yeah, we'll just cheat. We'll totally just cheat with that. And we'll do something like that. Yeah. Dun, dun, dun. Okay. Coming through. Do I like this syntax or this syntax? I'm kind of partial to this syntax where you see where each of them end. Even if that ends up being more lines, I do like the explicit correctness of the way this looks. Anyway, let's see. So we can do something like this. Make H1 selector. Div WHF selector. Yeah, we'll make a test selector helper function for this. And it needs to know about the elements, of course. So this can be something like this. Okay. Test selectors. and it takes a selector. And a set of elements to test it against. Test the selector, not selectors. All right, and then here we will just print out the selector. Selector.text, like that. And here we will do this. Node name and selector.matches element. All right. Look at us cleaning things up. Div ID WHF. Node name may throw. I forgot about that. That means that we have to make the test selector function throws. No big deal. Okay, so it doesn't match any of those elements, but what if we add the div element to the list? Still doesn't match. Neither does anything else. Okay, so I guess it's because we never actually implemented this thing here. The checks if a simple selector matches. We ask the get attribute thing, which doesn't do anything. So this would be something like attributes get name. What does that return? Oh, it returns an optional string. So I guess it's empty if you don't have it. So that would be the correct return type, but then this logic doesn't work because we can't compare a string, an optional string, to a string. That's interesting. Can we do it? Can we do this? Yes, we can. Still doesn't match here. Okay. Why don't you match? Let's see. That's interesting why it doesn't match. Now I'm curious. So let me just test something here. Div get attribute ID. What does that actually return? Okay, it gives us well hello friends as a string. So we are having the right attribute. The well hello friends selector checks for WHF, but it doesn't match it. Let's see. Why wouldn't that match? I guess we should just log what we are testing in the compound selector here. So we will log print line test compound selector matches, or test against simple selector element. We can even say what the result is actually. Matches element. Okay, so it says here, test this simple selector ID WHF against the element. False. So I wonder, am I doing something wrong here? Like, why doesn't that work? I feel like that should work. Let me spell this out. So we'll do this. element ID has value, and element ID is ID. Still false. Testing ID against attribute ID. The attribute ID is none. Why is it none? Wait, why is it none? That doesn't seem right. Get attribute. Oh. Wait. Oh, I see. I'm not getting the ID attribute. I'm getting the WHF attribute because I'm passing in the ID in the selector. Well, that was my mistake. How silly. So if you spotted that and you've been annoyed for the last 5 minutes, sorry. Then we can probably go back to simplifying this. True, it works. Okay, so there we go. Yeah, so I think maybe this is enough random prototyping for today, but I think this has been a very interesting exercise. And it really feels like the language is becoming very, very pleasant to write and to prototype in. There are some sharp corners for sure. And the error messages can be better. And we ran into some things that don't actually work. But man, I'm really, really happy with just how fast you can prototype stuff in this language. It feels like there's very little ceremony, and you can just kind of get to the point, which I really enjoy. So I think maybe the last thing I want to do is see if we can break it into multiple files. That would be kind of fun just to see if that would work. So let's make a directory for this. And we will split it into like a DOM and a CSS and a main file. That would be kind of interesting. And then we will split them out. So DOM, Jakt. Now we just need the CSS stuff. So we will nuke this, that, keep the CSS stuff, import DOM element. Can we do just that? Yeah. And all of this gunk we'll put into main, I guess. Oh shoot, wait, did I just mess everything up? Dang it, this was DOM Jakt. I was supposed to keep this one. Okay, let me start over. Delete the DOM. Import DOM element. Nuke everything else. All right, and then in main.jakt, nuke the DOM and CSS stuff. Keep everything else, but import DOM, import CSS, and keep the code like that. If this works, that would be so cool. Toy web main. It just works. Oh man, that's so cool. Man, big props to the folks who worked on imports and splitting stuff into multiple files. That is so sweet that I can just do that. I'm not constrained to a single file. All right. This has been very educational, and I hope that you enjoyed seeing the current state of Jakt and a little bit of random prototyping in it. And the language does keep changing. I'm sure it will look different next time we make a video, but the general concepts are pretty good, I think. We just need to refine, and see what we can do with it. Cool. Yeah, this will be the end of the video. So I hope you saw something interesting. Thank you so much for watching, for hanging out. This was a bit of an unusual video. I think we're going to get back to regular programming, of course, but I wanted to make something like this. So thanks for checking it out. I will see you all next time. Bye.